Okay, so admit issue is okay. When we say the Playfair cipher, in Playfair, when the letters are repeated, say uh, let's say Y and Y, or simple example, if I'll take, let's say hello, HELLO. So it means if we are using, there will be a chance in Playfair. In Playfair, we will see even in Playfair, if there is a chance, if L is going to be decrypted in with the letter of say S, so another letter will also be decrypted with the same letter S. So this is the issue. But in polyalphabetic case, if I'm writing say hello, then it might be possible that first L will be replaced with some other letter, say S, and second letter L will be replaced with some different letter, that is T, something like this. So it is called polyalphabetic case. Okay, so after this slide, there are some basic rules. I'm not reading out because once we will discuss the Playfair cipher with the example, then automatically we'll talk about all the things. So, or even we can say the Caesar cipher, as I told you that it was firstly used in the era of Julius Caesar, emperor, and the Playfair cipher, it was developed in Playfair cipher was invented in 1884, something like this, by Charles Wheatstone, one scientist. But majorly, the contribution in form of spreading the technique. So he was the person that we can call the Lord Playfair. So on the name of Lord Playfair, the cipher name is means we are mentioning here. And Hill cipher, it is another cipher technique that was introduced in 1929 by Lister Hill. Okay, so now I'm not wasting the time. Directly we will go to board. Now board is visible, Yogesh?
Yes, sir.
Okay, fine. So okay, so first, in quick way, we were talking about the Caesar cipher, and anyone if want to ask, then he or she may raise the hand. Okay, so on that case, I will unmute to particular one and I will respond. Okay, this is, as I told you, that this is single letter cipher, and in this case, what was the scheme? As I told you, now I am taking the small letters, then there will be no confusion. So letters are A to Z. This is a small one, and we will assign the numbers from 0, 1, a dot 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 up to 25. And when we talk about the encryption case, encryption in Caesar cipher, then it is nothing but that we know that encryption, after doing the encryption, will generate a cipher text. Okay, so I'm simply writing C for cipher text. Okay, now first I'm writing CT, that is cipher text, and it will be generated with some logic of encryption technique with the help of key, and this encryption logic is applied on plain text letter, because plain text is in form of letter here. We can consider this is the plain text. Okay, and in Caesar cipher, I'm not talking about the generalized version of Caesar cipher, but the particular case, the key is used here, that is 3, and plain text letter, and specifically there is no encryption technique, no encryption algorithm logic, no specific logic I'm writing here, no specific logic. Okay, so simply what they are doing, they are for doing the ciphertext with the plain text letter plus 3. So for example case, we can say that if plain text is suppose A, then ciphertext will be A plus 3. The value of A is 0, then it will be 0 plus 3, 4. Now 4 will be what? A, B, C, D. E, I think E. Right now, from this pool, 4 will become E na? C, D, E, 2, 3, 4. Okay, fine. Okay, and the possible combination for key, keys, we can write in this way, keys combination. Keys combinations. How many combinations are there? Can anyone tell me? Okay, someone is asking something. Anchit. I know it will be done. I know, but in quick, Anchit, in quick session, I will finish this thing. Okay, so quickly we will finish it. Okay, the combination key is 25, and in the similar fashion, when we convert plain text, then for decryption purpose, the logic for decryption is nothing but ciphertext minus 3, and we'll get back the plain text. Okay, so this is, and as I told you that mod of 26 we use mod of 26 because 0 to 25 total 26 numbers we are having, so all the calculations will be done on behalf of mod of 26. And even for the different we will also discuss the modular arithmetic in different lecture session. Okay, okay, now we will start immediately. Now I'm okay, not erasing, I'm just adding another board. Just wait. Okay, Yogesh, so the blank board is visible?
Yes.
Okay, fine. Okay, when we talk about the Playfair cipher technique, I'm just telling to you one thing that regarding the Caesar cipher case, that the brute force attack can easily be deployed here because only 25 possible keys combinations are available. And for the more complex than the monoalphabetic Caesar cipher, then we talk about the Playfair cipher. This is basically related to 5x5 matrix case. Okay, I'm directly going with the example. Let's say I'm taking one key directly. Key here, and key is nothing but monarchy. Okay, if this is the key and plain text, we can take something like this, anything, let's say hello. Okay, so very first step is to draw the matrix of or table, whatever you can say it, a 5x5 matrix case. Okay, so I'm just simply drawing 5x5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Okay, now the first task is to insert the key that is given to you for converting this plain text into ciphertext. So first step is to insert all the letters of the key in this matrix from left to right even. So I'm writing first M here, then O, then N, then A, then R, then C, then H, and then Y. We will see another example. If any letter is repeating in the key, then we will not write it again if we have written already in previous case. Okay, so this is the monarchy we have written. Now the rest, in the rest columns, in the rest boxes, we will fill the rest letters from A to Z. Okay, now A is there, already A is here, then we will write B after inserting the key. Then C is already there, then we will not write C again. D is here, then E is not E, then F, then G, and after that H is already here. And another thing, that 5 cross 5 is making the 25 boxes, but we are having 26 letters. So what we do, this is the predefined case that I and J combinedly we write in a same box. So we consider both the letters in a single case, I oblique J. After that K, and then L, then P, then Q, S, T, U, V, W, X, Y is already here, so Z. So now this is the first step is done now. Okay, so as I told you that if there will be any repeated letter in key, then we will not write it again, and the same fashion we will fill the all the stuffs. Okay, now the different rules. I'm taking the different color now. Okay, second step is to making the pairs of this plain text. Plain text is like hello, HELLO. Okay, so what we will do, we will make the pairs like HE. So one plain text is HE. Fine. Then L and L again. So letters are repeating here again in plain text. So what we will do, I'm just telling to you that when letters are repeating, then we insert letter X in between of repeated letters. Okay, so the case will be what? For this L and L, I'm separately writing this here like L and X. So this will be the next plain text pair, and the rest one, this L will be combined with O. Okay, so the first plain text is HE. Fine. I maybe give the numbers. Okay, the second plain text will be what? Not L, L, because letters are repeating here. So we may consider L and X because we have inserted the X already here. X. And the third plain text will be nothing but LO. Now the task is we have to convert the plain text into ciphertext. So for doing this, first we will consider the first plain text, that is HE. Now the corresponding ciphertext, how can we do this? Okay, so there are, I'm going back to the slide now for giving the just giving the essence about the rules. Okay, so I'm going back to the slide. So now slide is visible again, Yogesh?
Yes, sir.
Okay, so the rule is 5 cross 5 matrix. Then the first rule, repeating plain text letter. If there will be same pair, then we will insert X. We have done this. Now the rule related to the letters coming in same row, coming in same column, and in different row, different column. So when the two plain text letter fall in the same row, the matrix are each replaced by the letter to the right side we have to move. Then similarly, when the letters are coming in the same column, then the ciphertext letters will be the Banach one. And after the last one, when the different row and column are different, then we will use the thing row wise and column wise. Okay, just listen, because with the example it will be understood easily. Okay, now first we have to check this H and E where. So this is the H and this is the E. Okay, it means the third rule we have to apply now, because H and E both are in different rows. So what we have to do, first we will check we will move to row wise, and then we will move to column wise. Okay, so we will move to row wise from H, and then we will move to column wise from E. Then this will be the common letter. So we may write, we will replace H with C. Now in the previous case, we move the row wise for H and column wise for E. Now we will move row wise for E and column wise for H. So now this is the letter F, by which we will replace the second letter E. This is the case. Or the another example with the, okay, I'll take the different color. You can easily check the another example of same thing that is not included in this plain text. Let's say HA. Plain text is just wait. Hello. अभी मैं क्लास ले रहा हूँ, मैं बाद में बात करूँगा. Okay, so the let's say plain text is HA. Fine. Then ciphertext you can check. Now H is here and A is here again. So what we do? We will first move row wise like this and column wise like this. So H will be replaced with B. And for A, so A will be replaced like O, something like this. So this is the third case. Okay, now we back to our original plain text case. Our second case, or the second plain text letter, is nothing but LX. So this is the again the same case, like L and X are having the different rows. So we will move L row wise, then X column wise. So L will be replaced with S, and now for X, the column row wise and column wise with U. So this is the case. This is the only first case. Now I am taking another example, and in which all the rules we can justify. Okay. So now for doing this, I'm simply taking one key. Now key is nothing but Playfair example. Okay. So in Playfair example, this is the key. So again, first we will try to draw 5 cross 5 matrix. 1, 2, 3, 4, and 5. Okay, 1, 2, 3, 4, and 5. Okay, so we will write the key in 5 cross 5 matrix in this way: P, L, A, Y, then F, then A already is here, then we will write I oblique J here, after that R, then E, then X, A is already we have written, then M, and P, L, E, all the letters we have written already. Okay, after this the rest of the letters we will fill, like B, then C, then D, after that G, then H, then K, after that N, then O, Q, S, then T, then U, V, W, and Z. Okay, now I'm writing the plain text here. Uh, the plain text will be, uh, we can take some kind of the interesting plain text like hide the gold. Okay, hide the gold. Okay, so here first plain text is what? HI. Okay, now we can check. This is H, and where is I? Here is the I or J, whatever. So what we have to do, first H will be replaced. We will move row wise, then column wise. Row wise from letter H, column wise from I. So we are having this letter. So in ciphertext, we will have B, and for I, uh, the similar thing. Now we will move row wise and then column wise. So we are having letter M. So this is the concerned ciphertext of this. Now the different case I am considering here, let's say DE. Now plain text, okay. Plain text is DE. Okay, now we will check ciphertext. Okay, so D and E. Okay, this is the case of same column. So all the letters, Yogesh, it is, I am audible, na?
Yes, sir.
Okay, so when both letters are in the same column, so what we have to do, we have to move the lower side for D. So D will be replaced with the lower The Bennett letter from the D is O. So I will write O here. And the Bennett letter for E is nothing but D itself. So this is the ciphertext for DE case. And this is the case of same column. Okay, now for the same row, uh, we can take another example for considering the same row, because here I have to check what are the letters. So anything we can take like EX. Okay, this is the plain text. Let's say EX. Now ciphertext. So E and X both are in the same row, as you can see. Now what you have to do, okay, in place of EX, then it will be, okay, chalo is pehle C ko dekhte hain. So for E, we will move towards right. So towards right of E, here is nothing but letter X. And the towards right of letter X is nothing but letter N. Okay, so this is the case of same row. Okay, I'm taking another example out of this, even though you can solve this because we have to first make the pairs. Okay, HI, then DE, then TH, EG, OL, and one letter is short here, so you can append X at the end, and then you can make the pair. And one by one, you can do the thing. Okay, so another case of same row we can consider with the same example, like let's say A and F. For the plain text, I am telling to you, the examples are not, I'm not taking from the given one. No, isse nahi hai. I'm randomly taking the letters. So AF, AF. Okay. So this is the same row case. Now for the ciphertext, we will move toward right of A, then we will have Y, and again the right of F, you can see now you can move circularly like this. So for F, you are having another letter, that is P. So this is the ciphertext for AF, and this is again the example of same row. Now this, all the techniques, all these steps that we have talked about are related to encryption procedure of Playfair cipher. Now for the decryption purpose, okay, I can take another different color. Okay, for decryption case, what we have to do, the starting steps are same, means key you have to enter. After that, the rest of the letters you have to enter and make the key, make the matrix of 5x5 size. After this, we can take an example from here itself. Okay, now if we are having ciphertext like this, let's say OD. Now first we have to check that this is the case of which one. This is the case of in the same row, in the same column, or different row and different column. Okay, so OD, we'll check again and do the reverse process whatever we have done in the encryption case. Okay, so OD, both are the in the same column. Fine. So now we are at the decryption side. In the encryption, what we have done, when the same column letters are there, we moved Bennett letters towards Bennett letters. Now we will move the upward letters for the decryption case. Okay, so O is here. Fine. The upward one for O, the upward letter is nothing but D itself, and the upward letter for D is nothing but E. Now you can check with the same logic. We are having the plain text get back the plain text. And the same logic, same concept we can apply for the same row case. Even you can see for the EX is for the XM. Okay, this. If this is the ciphertext we are having, I'm writing here. If we are having ciphertext like XM, capital X, capital M, and we want to get back our message in form of plain text, this. Now, first we check what scheme, what kind of the rule we have to apply. The same row, same column, or different row, different column. So XM are here. This is the case of same row case. This one. Fine. So in encryption case, we move towards right, but in decryption case, what? We move towards left. That's it. Simple, very easy. So if we are having ciphertext capital X, then the left side letter of X is nothing but E, and the left side letter of M is nothing but, say, X. Now we can check that the logic is correct or not. So we are get back our plain text from the case of same row elements. So with this logic, we can do the decryption also. And for the different row column, the same thing we can apply here. Now I'm taking, okay. So for decryption purpose, I'm writing here decryption case. If we are having ciphertext, something like, okay, this one, BM, ciphertext like BM. Now we have to convert, or we not convert, we have to get back our plain text. So BM, we can check that this is the case of different column, different row. This is B, this is M. Okay, in encryption, what we have done, we first move row wise from B and move column wise from in this case HI. So first we move row wise, then column wise. Here what we will do, we will move column wise and then row wise. Okay, so B must be converted with H like this. Again this B and with the column wise. So H is, I think for doing the H, what we have done in encryption case, row wise and column wise, fine. Then we are having B, and for I, row wise and column wise, then we are having M. It's okay. Then for BM, we have to do the same thing. We move from row wise and column wise. Okay, then get back the H again. So there will be no issue. You can apply the same thing here for decryption purpose also, because there are two different cases. That's why. So for M also, now row wise and column wise, so we are having I itself. So this is the simple case of Playfair cipher, and I have to say the another thing related to Playfair cipher, that it is more secure than the Caesar cipher, as you can see easily. The reason behind it, we are having the 26 into 26 case, different case for the key size. For Playfair, we are having bigger number of size, 26 into 26. Why I'm talking about the key size? Because in all the cases, generally, we consider always that encryption algorithm is known to us, even though we have not started any algorithm, any encryption algorithm scheme. No, we have not discussed yet. We are simply talking about the substitution techniques only for cryptographic technique. But the general, like AES, Advanced Encryption Standard, DES. As I told you that in the net banking, for the net banking in India, AES scheme is used. Okay. So if AES scheme is used and the logic of AES is known to everyone, there is no issue, known to everyone, then how can you say that AES is very strong enough? And similarly, DES is also known to everyone. So the concept is, if the algorithm is generally known to everyone, but the key size matters. Here the key size is nothing but 128 bit, and we have seen in the last lecture, if key size is 128 bit, then brute force, if we apply brute force attack, then it will take a very huge amount of time for decrypting purpose. So in case of Caesar cipher, we are having only 26 key combinations, and the logic is known, obviously, +3 or whatever the logic we can apply, +3, +4, or even we can generalize it also. But still, we are having 26 combination, so security may be breached. And in Playfair, okay, the logic is known to us, everyone. We know, we have even discussed here. But the key size is bigger than the key size is bigger. This is bigger than Caesar cipher. So obviously this is strong enough, and with the same strong enough for the brute force attack or even cryptanalytic attack also. And for this is the examples that we will discuss once we will over the basic techniques. Okay. So today, for today's lecture, I think it is enough because time is again running out. So in the next lecture session, we will talk about the Hill cipher, and if you will have any query, still we are having 1 to 2 minutes. Still we are having 1 to 2 minutes. So I'm stopping the share.